Hi, welcome to the Daily Space for March 11th, 2019. Twitch is being twitchy. Thank you, all of you in chat, for discussing all of the problems you were having. Unfortunately, I thought I was streaming and that Twitch was having the problem. It turns out I started streaming. My stream stopped streaming. I failed to notice my stream stopped streaming. And then Susie texted me. Thank you, Susie. You are awesome. So to go back and repeat the things that I thought I already told you, and hopefully it will be better this time. Today is somehow the 11th of March. I'm not quite sure how this happened so fast, but I think it's because we have had so many rocket launches, so much science, and so many things going on so far in 2019. Well, today is a slow news day, and this gives us a chance to reflect back on some of the things that have happened throughout space history. My first story of the day is not something out of history, but rather it is today's new news. This is a story coming to us out of the University of Leeds in the United Kingdom that uses telescope data from the very large telescopes down in Chile. By putting these telescopes together, combining them into an interferometer, scientists were able to find two new binary systems that contain two extremely young stars that are massive in size. The first of these systems, PDS 27, is a system that is only about it's only about 8,000 light years away from the planet Earth. And the two stars in this system are massive enough to potentially go supernova, still young enough to be, well, fusing low mass atoms together. And they are located only about the same distance that Earth is away from Uranus. So imagine, if you will, two young, massive stars locating a point somewhere in between their surfaces, and their entire orbit would fit within Neptune, the stars, everything else. That is a tiny system for two massive stars. And not to be outdone, a second system, PDS 37, was also found. This system is a little bit bigger out. Thank you, Dr. WD40, for subscribing. Thank you. So these two systems, the second one, PDS 37, the stars in that system are in this case, further apart, 42 to 50 some odd astronomical units apart. So we're looking at a system where if one star was at the location of the sun, the other one would be somewhere out in the Kuiper belt. Now, finding this kind of a young binary system is so hard to do because, well, youth is fleeting, especially if you're a massive star. These stars very quickly evolve, and one of them's gonna go boom, well, in nearly the blink of a cosmic eye. In just a few million years, these stars can run out of materials to fuse in their core and go supernova, leaving behind perhaps nothing, perhaps a white dwarf, perhaps a neutron star. And if such a compact object is left behind, you're still going to have a binary system. But that new binary is likely going to be one where the meal of the day is your stellar neighbor, where we start to see signs of galactic, or rather stellar cannibalism, as one star eats material off of the other. So I'm so sorry to hear that there are so many different technological problems going on with the stream. I am still here, I hope. I think I'm still here. Anyways, so that concludes our tale of binaries. But one further thing. Trying to find things that are short-lived in the vast sky is hard to do because at any given moment we're looking out at an entire set of different populations of old stars, young stars, everything else. And because young stars are rare, because young stars are short-lived, the probability that they're going to exist at the moment in time in the places that we're looking for them to exist is very low. It's kind of awesome that these scientists have found 2 different sites that we can study to try and understand how these stars interact and just what all is going on when, well, the young stars are babies. In further news, we now have a story of times gone by. 43 years ago this week, Halley's Comet got invaded by an entire fleet of small interstellar or interplanetary spacecraft from places all over the planet Earth. To quote to you from a variety of different NASA websites, the 1986 apparition, this is referring to Halley's Comet, gave scientists the opportunity to closely study the comet, and several probes were launched to do so. The Soviet Vega 1 started returning images of Halley on 4th of March 1986, and the first ever images of its nucleus, and it made its flyby on March 6th. This was followed by Vega 2 making its flyby on March 9th. On 14th of March, the Giotto space probe launched by the European Space Agency made its closest approach of the comet's nucleus. There were also 2 Japanese probes, Susi and Sakigati. The probes were unofficially known as Halley's Armada. We sent an armada of spacecraft to go visit Halley's Comet. Now, you might notice that in that list of spacecraft, there was nothing from the United States listed. This is because 1986 wasn't just the year that Halley's Comet visited Earth. It was also a year of tragedy for the manned space program here in the United States. This was when we were launching the space shuttle, and on January 27th of 1986, we lost 7 men and women with the loss of the Challenger space shuttle. That particular Challenger was in the process of carrying up observational instruments to study Halley's Comet, and there was a second launch scheduled for later that year using the Columbia that was also slated to study Halley's Comet. After the loss of the Challenger space shuttle, the U.S. space program shut down for a number of years while we worked to figure out how to retrofit the space shuttles in ways that would make them safer for the astronauts on board. Now, luckily, other nations do share data, and science is truly international. It is one sky shared by one human race here on the planet Earth. And now we have a better global understanding of this particularly difficult to observe comet. Halley's is difficult to observe because, 1, it's orbiting the wrong direction around our solar system, and 2, its orbit is highly inclined relative to the plane of the rest of the planets. This means the kind of orbital slide in that was done by the Rosetta mission, where it basically, instead of sliding into someone's DMs, slid into their orbit. Well, we can't do that with Halley's Comet. Now, the next time Halley's Comet is going to come around, we are looking at 2061. So 40 years from now, are you ready? I don't know if I'll be here, but the comet will be. And here's to hoping that future apparitions bring us better science, and that we aren't going to have to wait that long, and that there will be many more Rosetta-like missions to explore other comets in the not too distant future. Now, to continue our tale of history, today is the anniversary, I guess, of the birthday of Urbain, and I'm going to pronounce this badly, I'm so sorry, Urbain Le Verrier. This scientist, who was born in 1811, was a mathematician, a physicist, an astronomer, someone who basically combined these sciences to innovate the field of celestial mechanics. He looked at the orbits of the outer worlds and calculated that there needed to be some other mass out there influencing what was observed. That world that he predicted was Uranus. And it was thanks to him and the coordinates that he sent to Johann Gottfried Galilei in Berlin that allowed Galilei to find Neptune the same night he received Leverrier's coordinates, and to find Uranus within 1 degree of its predicted position. This kind of mathematical prediction and instantaneous discovery, well, this doesn't happen ever, basically. So while other worlds have been predicted, Planet 9 right now being one, that same day discovery, you got to give it to Leverrier's calculations and to Galilei's observations. This was an amazing moment in the history of science. And that's all I've got for today. And I will now, if Twitch lets me, go ahead and take your questions. Now, the reason that I say if Twitch lets me is I'm seeing that a lot of you are having a lot of problems. So hopefully this will work. So while you're typing your questions in, I'm going to go ahead and remind you, please @ me in the chat with @CosmoQuestX. My name is Dr. Pamela Gay, and I am here to put science in your brains. The Daily Space is part of CosmoQuest. We are a program to help you learn and do science. Over at CosmoQuest.org, we are in the process of developing a whole new set of tools to allow you to explore other worlds, to map out where it's safe to land a spacecraft and where it's scientifically interesting to explore. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. And we are here thanks to the generous donations of people like you. You literally keep the science flowing. Thank you. We are so grateful for everything that you do to support us here on Patreon through your bits, subscriptions, donations, and more. Thank you. And now to look for your questions. Okay. I don't know why LeVar Burton came up in the chat, but okay. Okay, it did. Scrolling back, looking to see what I can find. Again, thank you all for letting me know that the stream was not streaming. Yeah, my OBS did report that I was live, and then apparently I stopped being live. Thank you for your patience and for staying. Okay. Hi, Zine. Let's see what else is going on. Scrolling again. Hello, Dr. WD40, and thank you for the subscription. And what I didn't say earlier was everyone should go follow Dr. WD40. Among other things, he was once upon a time, and I guess technically still is, an astrobiologist. He currently teaches biology in a university setting, and you can use his channel to learn more about the squishier side of science. If one of my mods can do a shout out to Dr. WD40, it would be great. He was also one of the founders of the Knowledge Fellowship, which is that Discord that I go to whenever I'm looking to figure out who to raid, because it is a source for learning who all is here on Twitch to help you put information into your brain. I like your line, CosmoQuest, more like Cosmo Best. I will say cheers to that. Binaria Plays. Are you referring to the tweet that I did with my 2 dogs up there? So earlier today, I did give my dogs a bark box, and Eddie was quite determined that he was going to be the one to open it. Yes, Mike Cassidy. Someone, if there was a planet between those stars, would get a sunburn real fast. Now, in all likelihood, any planetary disk around the binary systems that we discussed today, the disk would most likely be outside of the orbit of those two stars. They would most likely tidally disrupt anything in between the two of them, but you can still end up with planets on a much larger orbit, and you can even have, for a short period of time, a habitable zone outside of this kind of a binary system. Yes, stellar cannibalism. I'm glad you see me now. I'm glad I am here. Oh, Nak's here too. Nak can also get a shout out. She is another one of the educational streamers, and I have to admit I'm having a moment of not remembering which science she tweets, but she's on the science side of things. Thank you, Teresa Littlefield, for pledging over on Patreon. Thank you so very much. Can we light up the chat with all the rockets, people? Okay, scrolling. So Mike Cassidy, could they turn into a variation of Thorn Zitkow objects? I don't know. I just don't know. I'm sorry. Some things I just don't know. No, Paranor, we don't tell Space Force about the Armada from 1986, because they might, assume it's still out there or something. And the spacecraft are still out there, but I don't think they're dangerous. Okay, let's see. Okay, Arinstro, you are welcome to live forever. You and Fraser can do that. I, for one, am not sure I want to live forever, given science telling us what it does about our planet. If you like yourself, acknowledge that climate change is real, but don't go down the rabbit hole of reading all of the predictions for the future. It's really a good way to not want to live forever. LeVar Burton is amazing, but why did he come up? No, we were talking about Urban Le Verrier. Anyways, Reading Rainbow was a fabulous show. It still is. It came back, actually. Okay, brains are for thinking, not for feeding to zombies. It is true. It is true. Okay, Harnstone, now I understand. I succeeded in actually saying this guy's name. Probably not correctly, but I succeeded in saying it. So Veronica Cure is asking, where can she find the picture of the double system that I shared? It's actually an artist's illustration, and I'm going to drop a link to the press release into the chat. Daylight savings time is evil. That's all I've got. Daylight savings time is evil. I'm sorry, Europe. We're going to be very confused for a little while. We're going to be very confused for a little while. So it turns out that Canada and the United States switched to daylight savings time at a slightly different time than the rest of the world. So I don't know when things are right now. So Larry, I didn't know until you said something that one of last week's stories from here on the Daily Space was now on the is now an astronomy picture of the day. It just shows that good science gets around, and in this case, the good science made it onto both the Daily Space and onto the astronomical picture of the day. Yes, Arinster, it's not just tidal interactions, but also stellar wind and light pressure that would clear out the dust fields. So when we look at the region around stars, there's usually a gap, and the same kind of gap occurs around really bright accretion disks. And this is a gap where the light pressure is sufficiently bright, dense, all those things, that it exerts enough pressure that it actually is able to push matter out of the region around it. When you have very bright, hot stars, they're exerting a massive amount of light pressure. They have to be. It's this light pressure that is supporting the atmosphere of the star against gravitational collapse. It's when that light pressure turns off that the star explodes as a supernova. Now, in the system of these binaries, you have light pressure that is coming from both stars to, well, first of all, create a surface that you don't want to be on, where you have the two walls of material pressing against each other. You have tidal forces, you have all the high energy particles, you have everything coming out from those stars, basically making it a especially nasty place to be between those two stars. So don't go there if you like yourself. Not that we have the capacity to get there. Next is DNA focused. Thank you. Thank you. I simply had a moment of brain. Daylight savings time ate my brain. It's not a zombie, so it will give it back, but yes, Silvershot, sometimes ignorance is bliss. Oh, that's awesome that LeVar Burton has a podcast where he reads to adults. I also do that on my personal feed, Starstrider, in the evening. Lots of good stuff out there, as our Instro mentions. Looking to see if there's any more questions. I see a whole lot of discussion about daylight savings time, and it's horrible. So Hannah's Warverb asks, how does light have force but not mass? Well, this is that good old energy equals mass times the speed of light squared equals mc squared equation that Einstein came up with. It turns out that energy and mass are interchangeable in a lot of different ways. And it is easiest to think of light as transferring momentum, whereas each little photon takes its energy and exerts its energy on the stuff around it. That transfer of energy, that conservation of momentum is what, if you rearrange the letters in a slightly different way and take things into an account, this is the same thing as that force. So in a lot of different ways, transfer of energy, transfer of momentum, and force are all interrelated. One of these days, I really need to teach a basic kinematics course here on Twitch. So one of the cool things about this is if you get hit with a low energy photon, it actually has less momentum than a high energy photon, because it's that combination of the energy and the velocity that all works together, and all light travels at the exact same velocity. So light exerts pressure, and you are currently getting forced upon by the sun. If the Earth were flat, one time zone would work. Since it doesn't, clearly we aren't flat. You know, I'm pretty sure there's YouTube videos that try and explain, but those YouTube videos are crazy. And the Earth is not flat. If it was, it would be on the back of turtles and be far more interesting. So Bad Panda, if we stopped the Earth from rotating, there would be a great deal of instantaneous badness that occurred because of that conservation of momentum problem. You would keep moving even if the Earth didn't, and would promptly slam into things as they got sheared off the surface of the planet. Oceans would go over their banks. It would be bad. Do not wish for the Earth to stop rotating. Wish for the Earth to have never rotated or become tidally locked much earlier on. But then you have to worry about the weather, because a tidally locked world is only getting sun on one side. And yeah, we're actually glad the planet rotates while hating time zones. And trust me, I hate time zones. String theory responds, if Earth is already slowing its rotation, would that then result in a growing retrograde rotation? No. So it won't end up retrograde like Venus is retrograde. Instead, it will just slowly slow down until, given the fullness of time, ignoring the fact that the sun will expand, the Earth would end up tidally locked with the moon. And in this way, as the moon slowly went around, slower than it's going right now, because it will drift into a much larger orbit with this slowing down of the Earth's rotation. Conservation of angular momentum is the responsible party for all of this. As all of that occurs, we will end up eventually having a day that is the length of the moon's orbit around the Earth, the same way the moon has a day that is the length of its orbit around the Earth. So everything will all get lined up face to face. Okay, so let's see. Any other questions in here? Okay, so I'm not seeing any more questions. As it is the day of daylight savings time, which means everyone is suffering from not actual jet lag, but time zone switch jet lag. I'm probably going to end things a little bit early, and I am so grateful for all of you sticking around while I started things a little bit late. Here's to hoping that Twitch fixes all of its twitchiness as soon as it possibly can. As a software developer, I have to say kudos to them to maintaining their devotion to iterative design and regularly pushing changes to the servers. I get it. Bugs happen. And here's to hoping that there aren't too many sleepless nights as you work to get everything fixed. So thank you all, and I hope that all goes well for all of you wherever you are. Now I'm going to go ahead and run the credits, and while the credits are running, and of course I don't have the window open that will automatically start the credits, so I have to open it. If anyone wants to suggest anyone to raid, I am open to suggestions. I am also opening Discord to, as I said earlier, check out who is streaming currently according to the Knowledge Fellowship Discord. I am currently scrolling. Let's see. So right now we have a programmer and scientist, Adam13531, is streaming, and I will be rating him right after the credits. So everybody stay tuned. This show is going to end, but the science will continue, or at least the learning will continue. So thank you all for being here, wherever you are in the world. And have a fabulous morning, evening, or afternoon. And if the weather allows, get outside and look up. Bye-bye.